Nick Majerison here, welcome to Top Med Talk. And today we have a very special edition of Top Med Talk. It's a conference highlight. It's taken from a conversation that we had a year or so ago here on Top Med Talk. And it's a discussion about oxygen and the Xtreme Everest research studies into human adaptation to hypoxia. You can check out the Xtreme Everest expedition by going to the website and checking out the post that contains this podcast on topmedtalk.com. The website you're looking for is www.extreme-everest.co.uk. You'll find a link on the post that corresponds to this podcast on topmedtalk.com.
Top Med Talk. I'm here with Dr. Joff, Lacey and Professor Mike Grocott again, and a special guest who I'll introduce in a moment. Now, for this particular session, we are going to go right to the heart of the problem, right down to a cellular level, potentially, and we're going to talk about oxygen. Now, this particular team round the corner spent some time on Mount Everest in 2013, studying the Sherpas there, the indigenous population. But I want to start by reflecting on the fact that two of you summited Mount Everest and drew blood samples from each other. So, Mike Grocott, you're the leader of that expedition and the overall leader of the Xtreme Everest Oxygen Research Consortium. Can you tell us a little bit more about what it's all about?
So our ambition has been to understand more about oxygen and particularly hypoxia in the clinical environment by using a different model of investigation. So using the example of perfectly healthy people ascending to altitude where they are exposed to environmental hypoxia and making a variety of measurements to look at the differences between them. So the variability we see in ability to adapt to hypoxia, and then our ambition is to bring that back to the bedside in a translational route. We had 198 participants who ascended at exactly the same rate, which allowed us to make assumptions that any differences we saw between them related to their physiology as opposed to some behaviour on the way up. And they were studied initially in London and then at various points on the route up to Everest Base, including Kathmandu and Namche Bazaar, the Sherpa capital. And we took a whole set of physiological measurements, and we also took a large number of biological samples that we've been working on ever since.
Now, we'll come back to that broader group thing, but on the basis of our special guest we've got here, I want to talk specifically about the summit day. So you were part of the team, from our team, that were the first group to summit Mount Everest.
So we actually set out on my birthday, which unfortunately meant that we didn't get to the top on my birthday, but I'll get over that. We set out in the late evening, so about 9:30, 10 o'clock at night, climbed through the night, and then reached the south summit just as the sun was coming up, so about 5:30 in the morning, and reached the summit probably about an hour after that. And our ambition had been to take an arterial blood gas on the summit. So we had about -20 and about 15-20 knot winds, and we, I still think prudently, decided not to do the sample there, but descended about 400 metres to a structure called the balcony, which is a small flat area where our Sherpas had been able to erect a small shelter, and we ducked in there and took 4 arterial blood gas samples.
So why not just do it on the summit?
So we'd done a lot of due diligence in advance of going to Everest, and the kind of first assumption is we just do a simple radial stab, but it turns out that your radial artery essentially disappears in those sort of conditions when it's cold. And we thought through all sorts of more complicated and contrived methods of having permanent indwelling catheters and that kind of thing, but actually the simple and effective solution turned out to be a straightforward femoral arterial stab.
So drop your trousers, go for the groin.
Well, we got very sophisticated. We did at one point have groin zips,
okay.
Which attracted some interest from a variety of people, but in the end it was as you described, drop your trousers.
So reluctant to drop your trousers on the summit of Mount Everest when it's -20 and the wind's howling, correct?
Yeah, I was. Dan can speak for himself, but I was.
Well, you've given away the big clue, our special guest. So there was, in the team, there was obviously a larger team, but of the 4 people who had the gases drawn and drew the gases from each other, who were all medics. Can we get a name check on those?
So Sandeep Dhillon, Chris Imray, Dan Martin, and myself.
So our special guest, the clue is Dr Dan Martin OBE, who is an anaesthetist and critical care doctor from the Royal Free Hospital in London and a colleague of ours at University College London, but is also a legend. He's a record breaker, we believe. Dan, welcome.
Good afternoon, Monty. Thank you very much.
Already embarrassed you.
Yes,
so why are you? What record do we think you hold, Dan?
Well, it's quite possible that I have the record for the lowest ever recorded level of oxygen in the blood, taken from the blood gases whilst we were up there.
So of the 4 people, you had the lowest level of oxygen. Now,
yes.
We're now going to find out. So when you took the oxygen, when you'd summited Mount Everest, you came down. When the samples were taken, you were resting? Is that right?
So we were resting, and although, say, for safety reasons, we'd used supplemental oxygen at about 2 litres a minute to climb. But when we dropped down to take the samples, we took that off for about half an hour, and we were resting, lying down essentially, or semi-supine.
And so then resting for half an hour or so without supplementary oxygen, you put the needle in the groin, you take the blood sample, it gets taken away to an analyzer, all that stuff's been verified. You've demonstrated, we haven't got time to go into it now, that it's an artery, not a vein. The blood gas analyzer works well. What's the answer, Dan? How low could you go?
Well, I think the number surprised us even. It was 19.1 millimetres of mercury, or approximately 2.5 kilopascals, which translates into approximately 35% as an oxygen saturation, so markedly lower than you would see in any patients that we look after on the intensive care unit.
And how were you feeling at the time that you had that sample taken?
I think it's fair to say I've had better days, but there are a whole number of factors up there. You're also tired from an exhausting climb and hungry and thirsty. I think hypoxia is not the only factor there, but able to communicate with the other guys and take an arterial blood
gas.
Yes, yeah. I took Mike's, so we
lucky Mike.
We took each other's, which is very nice.
and broadly speaking, you were all around the same. I know you're the lowest, but you're all in the same sort of zone. What was the range? Any idea who was the highest?
All under 30 millimetres of mercury. So the highest was 29, I think.
Yep.
And yours was the lowest at 19.
Absolutely. Yeah.
So we think that sort of levels of oxygen are very damaging. We think that they would cause, for example, brain damage. But on the basis of the fact you seem to be working fine now.
I think the first thing to say is that we had a long period of time acclimatising to that low level of oxygen. So things were happening in our physiology and perhaps at a cellular level to allow us to tolerate those very low levels of oxygen for brief periods of time. And much of the rest of the expedition that Mike described to you is understanding what's going on that allows us to actually tolerate those low levels of oxygen.
So before we get on to that bit, I'm sure people are dying to know any residual effects that you're aware of. You don't have to get too personal here, but and I mean, if you had follow-up brain scans and things,
so we had neurocognitive tests performed on the mountain, and then afterwards, after we'd returned back to sea level, and there's no evidence that any of us were affected from a neurocognitive perspective by this sort of long periods of low oxygen levels, not only on the summit but also on the rest of the mountain. Living at base camp for a couple of months or so, we appear to have be unaffected by that.
So Mike, the big picture then, what did you all learn from the 200 or so people?
So I guess the key messages relate to actually what we'd set out to find, which was this notion that that tissue adaptation may be at least contributory and possibly more important than the sort of macrophysiology oxygen delivery that we've all thought about for a long time. So the classical acclimatization things around breathing more, increasing circulatory carriage of oxygen. And it turns out, and we know this in part from the 2007 trip, but also from the 2013 expedition that Dan led, where we were able to do more refined experiments, that both the microcirculation and the mitochondria undergo significant changes that may well explain the capacity to adapt to hypoxia over a period of time.
Okay, so let's jump forward to 2013 then. Dan, you led that expedition.
Yeah.
And we had a bit of role swapping around there. Mike was running the laboratory in Kathmandu. I was in the middle in Namche. You were at base camp.
Absolutely.
Another couple of hundred people coming through and some children, etc., etc. Now, Joff travelled the whole journey. He was out there as a research fellow, but you were also out there with a team that made a documentary, and to embarrass you, Joff, and many people may not know, you won an award for a documentary that we can find online. Is that correct?
Yes, I was there with the Al Jazeera English documentary series called The Cure, and we were following the whole Xtreme Everest expedition, and we won the Foreign Press Association Science Documentary of the Year. So you can find that on the Al Jazeera English website, but also on if you type in Xtreme Everest, as we said before, you'll find it on the website, link there as well.
And it's called Doctors on Everest or something of that?
Cure, Doctors on Everest.
So that tells the story. Dan, what was the twist, the added twist with this particular, the 2013 expedition? We'd had healthy volunteers, we'd had some children before, but there was a significant major extra twist to this endeavour.
What Mike and I and others found that whenever we would give a lecture about our findings in 2007 is that we were very commonly asked, what about the Sherpas? And the Sherpas are an indigenous group of high-altitude individuals. Their heritage is such that they've lived at sort of tens of thousands of years at high altitude. And these are the guys who race up and down Everest as if it was not at altitude at all. They are truly phenomenal. For many reasons, we didn't study them in 2007. So one of our primary goals when we went back in 2013 was to involve the Sherpas of the region in the research and test ourselves alongside them to see if they had any additional advantages from a physiological perspective that otherwise had not been identified. So that was one of the key reasons for doing that.
Joff, you travel with the Sherpas and with other people up through the mountain, and some of the footage in your documentary, you can clearly see their extraordinary performance characteristics, the children running around, people carrying heavy loads.
It was quite humbling as you're really working hard to this new environment, this hypoxic environment, and everyone around you, all the Sherpa people, are getting about their daily business as if walking down the high street. So quite a phenomenal thing to witness in real person.
So Dan, the group, maybe Mike can chip in as well. What appears to be the secret to Sherpa physiology?
So I think if you ask the average person in the street what it is that makes a Sherpa better than us, most people will say, well, they have a higher hemoglobin concentration. So that's the answer. And we knew that not to be the case. So we suspected that pure oxygen delivery may not be the reason that they're better than us. And as Mike alluded to earlier, we can see quite incredible differences in the way that their microcirculation works. So they have a much higher blood flow in their microcirculation and a much greater density of capillaries in their tissues. But perhaps even more exciting is the differences that we see in their mitochondrial metabolism. So to sort of simplify it, they are more efficient at producing energy than we are for a given amount of oxygen. So they're a much leaner burn, if you like.
And their physiology doesn't really change much, does it, between Kathmandu, where we did the baseline testing, and base camp? Now, I guess in some respects, you could argue you're looking at the wrong way around, because Kathmandu's the abnormal environment for them in some respects.
Absolutely. So you're sort of bringing them down from their usual environment, as you say, to a much lower altitude. And correct, as they ascend up to base camp, you're not seeing huge differences in what happens to them. They are so well adapted, perhaps at a cellular level, because they've just had so many generations living up at altitude to change.
And am I not right that if you actually calculate the content of oxygen in their blood, it's less than what us lowlanders have up at altitude?
That's correct, and I think people find that difficult to comprehend, that actually they're, from a volume perspective, they're delivering less oxygen to their tissues than we are, because we have this very high hemoglobin concentration when we go to altitude that just doesn't happen to them. And maybe for us that's actually a maladaptation, because whilst we can deliver, there are certainly lots of side effects from having a very high hematocrit.
Okay, last few minutes, the recurring question with all of this is that sounds very interesting, science for science sake, well done, career progression, messing about in the mountains. How's it really going to help?
So our belief is that through understanding those mechanisms whereby, in particular lowlanders, but also the Sherpas adapt, so new insights into both the microcirculation and in particular the mitochondrial function, we will be able to both predict those people who are likely to struggle more. So if you think of the critical care context, people who you would expect to have problems, that's appealing. What's much more exciting is the potential to, if you like, mimic the mechanisms that we see in what you might characterise as good adaptation, and the opportunity to manipulate physiology, probably through pharmacological means, and most likely through drugs that we already have available. We're just not using in the right way. So you essentially turn someone into a Sherpa if that's what's needed.
Top Med Talk.
And a quick reminder that you can catch the Xtreme Everest team live from Duke University on the 14th of June on topmedtalk.com. That's right, we're going to be streaming an event where they will be live telling us about what happened when they went to the extremes of Everest. topmedtalk.com.